Hi students, my name is Stephen Soti and I welcome you all to today's lesson. Today, I want to use the opportunity to talk about the GPS. The GPS. Has there been a time where you got lost somewhere and you needed to navigate your way back home? Our outline would consider the following: what the GPS is, how the GPS works. We'll see if we can be able to apply the GPS in finding our location, and then some benefits of the GPS. GPS stands for Global Positioning System. Global Positioning System. It is the only system that enables us know our exact position on Earth in any weather, anywhere. It's the only system that enables us determine our exact position on Earth anywhere, in any weather, and at any time. Any weather, because sometimes weather conditions affect navigation. There are three parts of the GPS system, or the GPS. These are the satellites, receivers, and software. If you consider looking at the top right corner of the slide, a normal GPS system or a simple GPS system can be represented where we have satellites up here. We have a workstation that contains software for analysis of whatever signal the GPS or the satellites up here releases to it. And then we also have the receiver. It could be your phone or the computer, or any gadget that enables you, that contains software that enables you find your way. The GPS constellation consists of 24 satellites. So looking at 24 satellites, in 6 orbital planes, and each orbital has 6, so 6 times 4 gives us 24. So at the top, the down right, you realize that there are 6 orbitals. So 1, 2, 3, 4, 5, and then 6 orbitals. And at each orbital, there are 2 pairs of satellites placed 20 kilometers in orbit, having a period of 12 hours, almost 12 hours. So there are 2 orbits in a day. Each satellite carries multiple atomic clocks. When we talk about multiple atomic clocks, we are talking about basically like a standard clock. That could be used anywhere. We said that As a GPS has three parts. We have the receiver and then the software. So if you want to look at the receivers and then receiver and the satellite, you want to look at the receiver or the satellite as the hardware component, and then the software as the soft component of it. The GPS units are made to communicate with GPS satellites. So there are units, okay? So you see a unit here, and a unit here, and a unit there, made to communicate, okay, in a dual way, send signals from these units to the satellite and then back to find out exactly where they are on the global scale of things. Now this, each satellite transmits data that indicates its location and current time. All GPS satellites synchronizes operation so that these repeating signals are transmitted at the same instant. So you realize that if you're having three satellites, transmissions or signals transmitted are coded, okay, in zeros and ones. Zero meaning off, and then on meaning one. So if you have these pulses as transmissions from three satellites, they're saying that they are synchronized in such a way that the repeating signals are transmitted at the same instant. And you see pretty soon how we use the method of triangulation to determine our position. How does the GPS work? The receiver picks up signals from the satellite. So we have receivers here. Okay, so you see the man here on Earth, and then satellites in space are distances away. So from here to here, it gives us a distance. From here to here are distances away, which we need to determine. And once we are able to determine, the GPS is able to determine the distance, we can also know the position. So this is how it's done. Now, from basic physics, we know that distance can be obtained by multiplying velocity with time. So if we know the velocity, okay, here we know that the transmissions are radio waves, okay, and radio waves behaves like that of light. So roughly, it should have a speed of 300,000 kilometers within 1 second. So if it takes 6 seconds to receive a signal transmitted by a satellite floating directly overhead, then by computation where distance is equal to velocity times time, then velocity being 300 and then time means 0.06 seconds, we can multiply and have it to be 18,000 kilometers as distance. We could repeat this for each of these satellites, and by triangulation we can be able to determine the position. The process of triangulation helps us to determine the position, our position at any point in time. Now we are saying that how does the GPS work? Continued. The GPS, the receiver triangulates. So the receiver now does the triangulation, okay, of the information or signals that has been received from the satellite. And this is what we mean. So we have the receiver receive a signal from this and then triangulates right? This satellite is in, so consider this satellite in its orbit, okay, going around, okay, emitting certain signals. Now, if we add one more satellite, okay, also releasing transmissions, okay, or radiation, or also radiating, realize that there will be a mix-up, and definitely there will be a point where you have them meeting, okay, as this. If we add another, realize that there is an intersection, a better intersection, and that we have a position 1 and a position 2. But we need to be double sure about the exact position we are. And so we add another one as this. And you realize that the best position to consider is this. We add another one to be double, triple sure. And here is our position. You realize that there is more coincision here than here. So we could make this as a choice of our position than this. Benefits of GPS. The GPS system, I want to say, is kind of a spill-off or a remnant from, or a fragment from certain researches that are being done by the US military. And so we can classify the benefit or the importance of GPS application into two groups: for our daily lives, domestic use, as well as military usage for missile distribution. For military, we can probe further and say that, I want to talk a bit about that and say that the GPS system was completed in 1994. Since then, it has proved to be a valuable aid to the US military forces. Where in the middle of the desert, all you can see is the sandy terrain of hundreds of miles. It will be very easy to get lost without the use of GPS. GPS allows the soldiers to be able to maneuver in sandstorms at night and pinpoint exact locations to help win the war and protect lives. I want to say that 1,000+ portable commercial receivers were initially purchased for their use. The GPS proved to be a successful tool, and by the end of the war, more than 9,000 commercial receivers were used in the Gulf of Guinea, or the Gulf region, Gulf region. GPS were carried by soldiers on the ground and were put into vehicles, helicopters, and aircraft instrument panels. GPS is very important to all aspects of military operations and weapon systems. It is used on satellites to collect extremely accurate data. In our daily lives, GPS systems can be applied everywhere. GPS systems was developed to meet military needs. New ways to use its capabilities in everyday lives are continually being taken advantage of in everyday life by normal people. Many place fire and emergency medical service units use GPS. It helps to save lives and property across the world. In 2002, it allowed rescuers to drill a shaft to free trapped miners in Somerset. Fear. GPS-equipped aircraft can quickly plot the perimeter of a forest, so fire supervisors can produce updated maps and send firefighters safely to key spots. Mapping, construction, and surveying companies use GPS for their purposes. Many people use GPS in their car to help with direction. Thank you for watching, and watch out for our next lesson.